Let's start recording. All right, guys. So tap mode, right? Thanks, Ram. Right, guys. So tap mode, right? Tap mode is generally it's not used in a production environment. 99% of the time you will not see any deployments where firewall is deployed in tap mode. The reason for that is because firewall will not be able to take any action on the traffic, right? The only action that is taken from the firewall is do the security inspection and drop the packet. So, for example, let's say you have a okay, let's say you have a switch. Okay, this is your switch, and your network segments are connected over here. It could be a LAN segment, and then this could be your WAN segment. I'm oversimplifying things, right? I'm not getting too much into the or network topology for now, but fine. So LAN segment and WAN segment, and this could be your core switch. Okay. So what you will do when you have to deploy the firewall, let's say you are a sales engineer, you visit an organization and they are like, okay, but we'd like to see what your firewall can actually do. And at the same time, we don't want to install it in our network yet, right? Because we are not ready, because there needs a lot of planning before you are ready to install a firewall in the network. So what we would like to do is, can if there is a way wherein you will be able to demonstrate a capability without actually installing the firewall in the network part, right? So what the sales engineer will do, okay, all right, what we can do is we'll take our firewall and then we will take a span port or port mirroring, right? This process is called as port mirroring, right? And then port mirroring is nothing. Whatever traffic is going through the switch will make a copy of all the traffic and will send out through this port. Okay. And then that particular port will be connected to our one of the Ethernet port. It could be anything. Ethernet 1/1 to whatever you'd like, right? And then this interface will be in tap mode. Okay. Now, what firewall will do, uh, the firewall will receive this traffic, will subject it to security inspection, right? Once the inspection is done, it will drop the packet, right? So if you see, we are not taking any action because we are not in a direct network path. Okay. We are just there to do the security inspection. And once it is done, we are dropping the packet. That's it. No action. But then what is the significance of this? The significance is visibility, right? What we are trying to create is visibility. This will give you insight on your traffic, on threats, on URLs, on if there are what kind of files, right? So it will give, and then it will also give you information about uh, source or destination, right? So you will be able to have a look at all these information on the firewall, and then you can compare and contrast with your existing security solution as to which one is better, right? Which one is giving you better visibility, and then a more robust mitigation control, right? So this is where your tap mode is actually deployed. All right, I hope that clarifies your doubt. Okay. Tap mode is acting as IDS. Yeah, obviously, I mean, we are just detecting, we are not able to do anything, right? Because we are dropping the packet. So it's sort of like an IDS, you can say. Yeah. But again, I mean, I really don't like the word IDS because it makes you feel like you do not have any capacity to take action, but that is not true when it comes to the firewall, right? So our Palo Alto firewall can actually take action on the traffic. It's because of the way it is deployed. It is not, it cannot do anything, right? So, but yeah, in a way, you're right. It's true. IPS is intrusion prevention, right? Wherein you, when you deploy it in a network path, it will be able to detect that threat. And then based on the action that you set, it will be able to drop the packet, right? Or deny the packet or deny the session or whatever, right? Whatever action we configure. So it has everything, IDS, IPS, everything inbuilt, right? You don't have separate modules for that. We have a single content inspection engine. We have a single app ID inspection engine. So these things are integrated. Okay. What is the basic difference between IDS and firewall? See, IDS can be a standalone, uh, equipment in your environment. Uh, then the role of that IDS is just it detects. It will give you some logs wherein it will be able to say, okay, this threat is detected. That's it. There is no actionable security over there. It is not going to take any action. There is no mitigation. Uh, Mitigation configured on that IDS, right? It is just a way that it will tell you, okay, there is some threat, or this is the threat I have detected. Now, whatever you want to do, you will have to, design your strategy and then act upon it. Nowadays, you won't see this to be, very effective, because you can see the packet rate is very high. By the time your IDS gives you that, okay, there is a threat, and then you think what needs to be done. By that time, the malware, or it would be infecting your entire environment, right? So we generally don't prefer that. Tap IG, tapping and tap mode is same, right? I'm not really sure if it is in context to the firewall, then yes. If it is in context to something else, I'm not really sure, right? But if you say you need to tap the stream, then that is what we are doing over here in the tap mode, yes. Does tap mode needs to be in any zone? Yeah, tap zone. So when you deploy, I mean, we have seen it, right? So there are, yes, in yesterday's session, we reviewed the types of zones, right? So for tap interface, you will have to assign a tap zone, and then you can configure any, wide open rule, because we don't want to drop anything. It will be dropped automatically. But yeah, does tap interface on the firewall need to have IP configured? Will they be in trunk mode, access mode? Not really needed, right? IP, you will not get an option for that, right? Because it is in tap mode, it's just receiving the traffic. And again, trunk mode, access mode, we really don't care, right? Because you are getting a copy of the traffic, you're not getting the actual traffic. So you're not going to do anything like, forwarding the traffic or something like that. So you are gonna get all the traffic to you, okay? So this is not going to be in any mode, trunk or access. It's simple tap mode with respect to the firewall. And then whatever configuration you do on the span port is different. Okay. So if we want to configure as IPS, PA will be inline. Yes, that, I mean, if it is not inline, you will still be able to do the inspection and everything. But again, in order for the routing decision, if firewall is not able to take the routing decision, then it will not be able to take any action, right? If you have to drop the packet, then it has to be in line, or deny the packet, or whatever, right? Whatever action needs to be done, it has to be in line. Can we do port mirroring in firewall? No, we don't have port mirroring option in the firewall. There are separate licenses or devices that could be used, like decryption mirrors, right? But again, altogether a different conversation. But yeah, we don't have uh, port mirroring that we can configure over here, but there is something called as decryption mirror that could be configured. Yes. All right. Cool, guys. Great. It was a good discussion, and thank you for all those questions. Keep this engaging like this. This really is helpful. Okay. So let's get on to today's agenda then. Yeah, I'll clear this out. Let me bring the. All right. So module 3, right? So day one is done. Security policy, we will see today. Interface zone types appropriate. This is done. This is done. We have to do this today. And we have also seen this, right? Now there's, I think, one thing left. I did not copy it properly. Yeah, interface management profile. Cool. All right. So let's start with interface management profile. And I also will give you a very simple information about virtual router because I want to cover everything that we have done in day one config. Just because again, there is a module 4 which will have everything related to virtual router. We'll talk about routing and everything over there, right? So let's first talk about interface management profile because interface types and everything is just clear in our mind as of now. All right. Let me open the lab and see labs. Sub-interface will come to it, Ganesh. Actually, I'll need to make a better topology so that we'll be able to get it. Don't worry, we'll cover that sub-interface. But just so you know, sub-interface is nothing different. It's sort of a layer 3 interface that you can build with a tagged interface, right? Where you will have certain VLANs and coming. So the topology becomes a bit complicated. We'll talk about it, don't worry, but maybe not at this point in time. So, so that we can continue with our flow, and then when we reach that point, I'll touch that point. Okay. Cool. Let me close this lab. Okay. We'll go here. Cool. So let me delete this, not needed because I have created a separate lab for this VWire. Okay. Start this. Oh, wait, let me import. All right. So meanwhile, these devices are booting. Let's talk about let's talk about interface management profile. Okay. Now, interface management profile is used so that you can allow certain management functions for that particular interface. For example, uh, we have layer 3 interfaces, right? Like you configured Ethernet 1/1, 1/2, 1/3 as a layer 3 interface. Now, obviously, when we have configured them as layer 3, we will try to assign an IP address. The IP address is assigned, everything is fine. Now, you if you have a system, okay, if let's say now let's say this is your LAN side, okay, and this is your PA firewall, this is your ISP, okay, and here let's say this is my Ethernet 1/3. Okay, you have configured this as layer 3 interface and you have assigned an IP address of 172.16.1.1/24. That is the subnet mask. Okay, and now this Windows machine, let's say this is Windows machine. This Windows machine has an IP address. You have assigned it an IP address of 172.16.1.2/24. And obviously for Windows machine, we need a default gateway so that they will be able to exit out of, I mean, to reach out to any other subnets, they will need that default gateway, right? To reach out to the internet or anything else apart from their own subnet, right? If it is in the same subnet, it will just do the ARP and will be able to reach out to it, okay? So here, the default gateway that you're going to use is 172.16.1.1, right? That means this is the IP address of the Ethernet 1/3 interface on the PaloAlto firewall, okay? Uh, Obviously, it's a very simple and straightforward thing. For example, if you're not able to reach out to the internet, what you do, you try to ping your default gateway, right? So whatever gateway you have, whatever router you have installed in your home, whenever your internet is not working, you'll open up your command line and you'll try to ping your router, right, which is your default gateway. And if you're getting a response, good. And if you're not getting a response, you will assume that there is something wrong with my router itself, right? But if you are able to get past your router or the default gateway, that means you have the connectivity. There's something wrong, might be at the server end. But Palo Alto is a security device, right? So everything that is headed towards Palo Alto is an implicit deny, right? Now, if you try to ping from 1.2 to 1.1, you will not get a response. Even though this interface is up, this interface has an IP address, up, learning, everything will happen, but you'll not get a reply. Why? Because pings are denied by default. You will not be able to get any reply by default unless you apply an interface management profile and select ping over there, right? This is what we have done in our day one config. If you guys remember, there is an interface management profile that we have applied to our LAN interface, right, which was our default gateway for LAN side. Okay, so you need to enable that ping, and once you enable that, you will be able to get reply for your default gateway. Now, enabling ping might not be a good idea if it is an ISP interface, right? Let's say this is your Ethernet 1/1. I mean, you can do, I mean, there is a functionality that you can achieve it. You can apply an interface management profile to this interface. But the problem is, this also increases your attack surface, right? Your hackers or any other bad actors, they will be able to know, okay, this is the interface, and I'm able to ping it, right? So this interface is up, this is the IP address, and they can get a lot more information just based on that. So the rule of thumb, never apply interface management profile, or never allow public interfaces, right, which are having a public IP addresses which might be reachable through internet. Do not expose it to services like ping, HTTP, or HTTPS. Okay, so we just talked about ping. Now, what all other management configurations that we can do is access the web GUI. Right now we have management interface connected to the management PC, and we are able to access the GUI of the firewall through the management PC, right? Firewall has a provision, Palo Alto Firewall has a provision wherein you can enable HTTP or HTTPS service on this particular interface, or any data plane interface as well. And then you will be able to access your web GUI from that interface as well, right? Provided now, for example, we are able to reach 172.16.1.1. That is our default gateway. Now, if I apply an interface management profile that says ping check, and then I say HTTPS. I mean, we have an option for HTTP as well. Not recommended, because HTTP is a clear text protocol, but we do have that, right? And then we have something called as SSH, right? We'll see all this in a minute once the device boots up. So if I check HTTPS and apply that interface management profile to this interface, your Windows machine will be able to type the address https :// 172.16.1.1, and you will be able to access the web GUI in the sense graphical user interface. Okay, so if you remember, the management interface IP address is 192.168.1.1, but we are accessing the web GUI of the firewall from 172.16.1.1, because that is the data plane interface and where we have attached the interface management profile. So that is the use of this interface management profile. You can allow management services as well as network services. Let's go ahead and see if our firewall is booted up. All right, looks like it's booted up. We have an IP address assigned. Okay. Guys, I mean, I'm not saving the configuration for these Windows machine. It's a simple IP address assignment. Even if it is not there, I'm pretty sure you guys can do that, right? Everyone knows it, right? So I'm not paying too much attention towards Windows machine. I'm focusing more on the routers and the firewall configuration so that whenever boot up your lab, you have router and the firewall configurations with you when needed. Okay. As of now, whatever we have done, it is from scratch. So we do have that config you can load using the import. I'll show that as well towards the end, and then you'll be able to import it and see that reference configuration for you if you'd like to do that. Okay, cool. So let's access the firewall. Let's see if this Windows machine has the IP address. Let's stop this and stop edit. Okay. So we have our web GUI, and this is Windows machine as well. Let it start. So once again, when you log in, you will land on the dashboard page, right? Uh, we have seen network tab and policies tab so far. Uh, in order for the interface management profile to be configured, you'll have to navigate to network. So far, we have seen interface, zones, virtual wires, virtual router, and we have at least navigated to these tabs at least once, right? Uh, so, in order to apply interface management profile, you need to navigate to network and then network profiles, interface management, right? This is the profile that we have actually, applied earlier on the interface. Let me show that to you. So you can see this is Ethernet 1/3. The management profile is allow ping over here, right? That is, Ethernet 1/3 has a ping allowed. Okay. And naming, I mean, general recommendation is give the name in a way that you'll be able to understand what all services have been enabled, right? So allow ping. Let's try to assign an IP address to this Windows machine and see if we are able to ping it. 172.16.1.2.255, and default gateway is 172.16.1.1, which is your firewall, and then the DNS servers. Okay, let's close. Okay, and sorry, I have to initiate a ping first. So if you see now, ping 172.16.1.1, you're able to get a response, right? That's good. Now let's try and remove this interface profile from here and see if we are still able to reach. So advanced management profile, I select it to none, click on OK, and let's do the commit. Let's give it a minute for the commit to go through. You can close that task and then you can open that commit job from here, task, right? This will have the entry of all the jobs that are currently running on the firewall. You can see commit job is at 98%. If you'll click on this, you will be able to get the same window back and check on the job status that is commit. Okay. So it's almost done. Let's close this. So the commit completed. All right. Let's go ahead and see if this ping is successful. Request timed out. Right. So we are not able to get the response, right? Reason I just demonstrated to you that the interface management profile has been removed, right? Let's see what all options are there in an interface management profile. Okay. So administrative management services, right? That we talked about HTTP, HTTPS, Telnet, SSH. If you'd like to take the web GUI of this firewall through an HTTPS, then you need to enable HTTPS. And if you would like to do an SSH, that is access the CLI of this firewall, you need to enable the SSH service. Now, same HTTP and Telnet are also available, but these are clear text protocol, highly not recommendable. These are like, last resort, something went wrong, and this is where, or maybe your environment does not support HTTPS or you need Telnet only for some reason, right? So you can use this, right? But again, my personal recommendation, you never have to do HTTP or Telnet enabled, right? Now, if you enable HTTPS, you'll be able to get the web GUI, like we are able to get the web GUI over here. And SSH will allow the SSH service to be, enabled, or you'll be able to access the CLI of the firewall through that interface, wherever this interface management profile is applied. Okay. If you talk about the network services, the first is ping that we already checked right now. Then there is HTTP OCSP. That is the OCSP is used for validating the certificates, if it is a valid certificate or if it is revoked, those kind of responses, right? SNMP is simple network monitoring protocol, wherein there might be some monitoring devices where you would like to enable this service on this interface rather than doing that on the management interface. Okay. Response pages are simple. When something is blocked on the firewall, you get a response page, and these kind of services. But we'll see about it. I mean, there's nothing too crucial. It just sort of like, if something happened, for example, if SSL decryption, you want to serve an opt-out page for the users, you can use this service. You can enable this service, and then your response page will be served to that user, which is coming on that particular interface. What case we used in Telnet? Honestly, I mean, for example, let's say now you enabled an SSH. Yeah, mostly we don't use it, honestly. I mean, no one uses Telnet in nowadays. But sometimes for some reason your SSH keys are not working. You don't have that SSH keys in your host machine, or something is not right in that case, and you need to, you are accessing it from your secure environment, but you don't have an SSH keys in your machine, and then because of that you need to first access the firewall and then do something with the SSH host keys or something like that. In that case, you can use Telnet. Sometimes nowadays, if you apply an SSH profile, I'll show that SSH profile that is applied on the management interface, wherein certain protocols are actually weaker encryptions are not allowed. And then once you do that, you have to restart the SSH service. But because you applied that profile, you lost the access of the CLI. So then you have to enable the telnet service so that you'll be able to get the access. But again, I mean, honestly, there are workarounds. You really don't have to enable telnet 99.9% of the time, okay? Unless it's of very, very crucial important. I mean, uh, that is the only option available to you, right? Cool. So user ID, we'll see what is user ID, wherein a user information will be available on the firewall. If you'd like user ID service to be enabled, you can do that. Then again, these are related to user ID, where one is syslog listener for SSL and syslog listener for UDP. Don't worry about this terminology. We'll discuss that going down the course. Okay. Now you might be able to see something called as permitted IP addresses. Now, permitted IP addresses is nothing but an ACL, right? ACL is access control list, right? What I will do, for example, right now, I want 172.16.1.2, which is this machine, only to be able to ping 172.16.1.1. I don't want any other machines to be able to ping, right? Let me see what we have here. Let me set Windows 7 and we'll start it, okay? So permitted IP list is where you can define the host information or a subnet information that should be able to access these services. Okay. So right now I have entered 172.16.1.2/32, which is this machine. Okay. And I have enabled HTTPS, SSH, and ping. All right. These three services. Click on OK. We'll go to interface. We'll allow it to we'll apply that interface management profile again to 1.1. And let's call that management profile. The name was allow ping, but we have enabled HTTPS, SSH, and ping. Okay. Click on OK. Now you see this warning that you get by attaching this interface management profile to this interface. You are potentially exposing the firewall's administrative interface to any party that can reach this interface. Okay. Now I'll click on yes. We have applied this profile. Let's do a commit. Give it a minute. In the meantime, let's assign an IP address to this Windows machine. We'll give it 172.16.1.3. And default gateway will be again 172.16.1.1, which is our firewall interface. And we'll give 8.8.8.8, 1.1.1.1. After adding IP, warning was not expected as we wanted more security. Please correct me. After adding IP, warning was not expected. No, that warning will always be there, Ganesh. Whenever you apply an interface management profile, that means you are exposing that interface, right? So no matter if you add permitted IP or you don't add it, you will get that warning. Okay. This is sort of like a intimation that now this interface will be exposed to whatever services you have configured. Please be aware of that, right? Because when that increases your attack surface. Okay. Cool. So I guess the IP address is assigned. Let's see, the commit is finished. Yeah, the commit is successful, right? Let's check from this Windows machine. What's the IP address? IP config. This is 1.3. This is 1.2. Let's check the ping if they're working again. So the ping is working back again. Okay. There is a role of security rules as well in this, but we'll talk about it in a minute when we'll be discussing that security rules, right? Right now, focus on the interface management profile. Uh, so 172.16.1.1 is reachable from 1.2, right? Let's try now because that interface has an interface management profile applied. Let's see if we are able to reach it from a second machine. It is in the it has the same default gateway as 1.1, right? Let's try to ping 172.16.1.1. You'd be able to see the request timed out, right? 1.3 is having a default gateway 1.1, which is definitely reachable. We know that because 1.2 is able to ping it. Definitely 1.3 should be able to ping it. The problem is we have actually assigned a permitted IP, right? So only the permitted IP that is being assigned will be able to do all the services or will be able to access all these services. So you can see I have assigned a permitted IP address of 172.16.1.2 slash 32. Slash 32 means that's a single host that will be able to ping, take the HTTPS access and take the SSH access of this particular firewall from that particular interface, which is your where this interface management profile is applied. That is your Ethernet 1/3, right here. Cool. Let's see if we are able to access the firewall web GUI 172.16.1.1. Great. We are able to access the firewall web GUI, right? Let me show you after login. Test at 1, 2, 3. So we are able to log in to the firewall. And you can see the IP address that I've entered is 172.16.1.1, which was the default gateway for this Windows machine, right? Let's see if we are able to do an SSH. 1.1. Yes. Admin test at 1, 2, 3. That works like a charm, right? So right there, we are able to do an SSH. We are able to do HTTPS, that is access the web GUI, and then we are able to do the ping. Let's try the same from the other machine. So pings are not working clearly. Let's see at least if we are able to access the web GUI. .16.1.1. I'll let it load and let's try the putty. So the browser is like trying to reach the page. It seems there is no response, right? You can see error connection timed out. That firewall never responded back. Okay. And the same will happen to the SSH session as well. So permanent IP address, in short, is very important and a very significant feature when you are enabling the interface management profile because it's only the users or the super users should be given the access. Not everyone should have the access because that might be catastrophic, right? So this is where you can enforce the security or simple ACL that will prevent or that will give access to only specific users or specific IP addresses, to be very precise. Only users coming from a particular IP addresses will be able to access these services. Okay, cool. Any doubt? Any questions related to this? Sorry. Why don't the management IP 192.1.1 not reachable from 1.2? I can understand that is gateway, but in production environment for monitoring purpose, we need to have the same management IP to be reachable. No? See, see the network topology, right? I have already informed you guys, right, that the management plane and data plane is separate. So it is not like data plane traffic will be sent to management plane or management plane traffic will be sent to data plane. No, this is a separate interface. It is not a part of your virtual router. Management interface will never be assigned through a virtual router, right? So this is a part of management plane. These interfaces are part of your data plane. That is the reason if you'll try to ping from here to here, you won't be able to get a management IP address ping. 192.168.1.1 will not be reachable through this. You can make it reachable though. Like how you can do that? Let me show you. Let's take a snip of this. Okay, so how you can make that reachable is putting inserting a switch, and then this management will go like this, right? And your this LAN will also go like this. Sorry, it might look a bit complicated, but I hope you are able to understand this. Okay. So this data plane, instead of going here, it will go to this. So in short, this is getting complicated. Let me draw it for you. So this is my firewall. This will have a switch, right? My management, my data plane, and so this is Ethernet 1/1, Ethernet 1/3. And then this is going to ISP router, internet. This is switch. And then this is going to this could be another switch, right? Now, this machine will be able to reach both management as well as this interface, okay? But in reality, management and data plane are separated, okay? The management interface is not a part of data plane interface, which are, which have to be assigned to a VR. So this is not a part of a virtual router, okay? Can we also add MAC instead of IP address? I mean, IP plus MAC. Yes, you can do that, Ganesh. There is a way wherein we can add that. Okay. Let me show that to you. I mean, we do that for troubleshooting unless, I mean, you don't want to statically assign a MAC address. But yes, you can do that. This is my Windows machine. I'll not do it from here. Let me do it from here. So, interface. If I come down here, advanced. So you see these ARP entries, right? So you can assign an IP address and a MAC address over here combination. So this is where you can add the ARP entries on that particular interface. Sometimes, you need to hard code. If you would like to hard code the ARP entries, you can do it over here. Otherwise, ARP protocol is already running and it will learn it dynamically. And then there is a ARP lifetime that will be applicable. That is 300 seconds or 5 minutes. based on which the ARP entries will be cleared and then learned again, right? But if you want to hard code it, you can do it over here. Okay. Cool. GUI page for IP 192.168.1.1 and 172.16.1.1 are same. Yes, Ram, it will be exactly same because we are accessing the management of the firewall, right? So you won't have any restrictions. It is complete management that will be accessible on both the interfaces. Ideally, it will be through 192.168.1.1 because that is the management interface. But then we have enabled the management services on 172.16.1.1. So you will be able to access the same management service, everything that is there on the GUI. There's no restriction. Okay. Cool. So I guess we are clear with the interface management profile. I'll head next towards a brief explanation about virtual router. Again, as I mentioned, I'm not going to go too deep in that virtual router thing as of now because we have a whole module dedicated for that. Uh, cool. So, virtual router, you have to navigate to network and then virtual routers. Now, here, what exactly is a virtual router, right? So, this is my firewall. Okay. I have certain interfaces, right? This could be Ethernet 1/1, 1/2, 1/3, 1/4, 5, and 6, right? And then, you have now there could be a layer 3 router over here. This could be in your environment, right? Or LAN environment. It could be layer 3 router. Let's name it R1. And then there could be a ISP router. Let's name it R2, right? And then there could be a layer 3 switch somewhere. Okay. Anything. Now, these routers have capability of routing IP, right? So these will be able to forward or route the IP packets, right? And then these are capable of running the dynamic routing protocols like RIP, OSPF, BGP, ISIS, right? EIGRP. These are the routing protocols that you can run on a router, right? And then definitely static routes you can add in order to point a route in a particular direction, right? So these capabilities will be there. But now firewall also has this Ethernet interfaces, right? So you are receiving a packet on this interface. And then after doing all the security inspection, you need to decide where this packet should go, right? So let's say this is coming from LAN. And so let's say there is a packet P1, right? It came on Ethernet 1/1. We did security inspection on this packet P1. And now after that, we need to send that packet out somewhere, right? There is no point if it does not reaches the destination. Now, for the sake of simplicity, let's say this packet is to be headed to the internet and my 1/4 is connected to my ISP router. Now what? I need to forward it through 1/4. That means what we are doing routing, right? In order to do that routing, we also will need a router. So we cannot have a physical separate router. We have an inbuilt virtual router. So this is my VR, right? Now this VR will be very similar to what a physical router that you see, right? Some of the things might not be there because this is virtual, first of all. And then it does not support all the routing protocols, right? For example, EIGRP, which was Cisco proprietary, is not supported. ISIS is not supported. We support RIP, OSPF, OSPF v3, and then BGP. That's it, right? So these are the dynamic routing protocols that are being supported. We support multicast and then we support static routes, right? So these things, and then again, ECMP is something that we'll be able to do over here, right? ECMP, that is your equal cost multiple path. Don't worry, we'll have a lab for all this, right? I'm just giving you a very, simplified explanation right now, okay? So now this P1 packet was done, inspection was done. Now there was a route lookup on this VR, and this said, okay, this has to go to internet using the static route. There was a default static route that was added, and then based on that, we forwarded the packet through interface 1/4, right? So that is the role of your virtual router. Now, you can say, Amol, I have certain need where, I might need two virtual routers actually. So fine, you can have that. There is no restriction. We have, you can add multiple virtual routers. So default is the virtual router that comes pre-built with your firewall. Whenever you boot up your firewall, you will see there is already a virtual router default, right? If you don't want, you can either rename it, you can rename it, right? You can change the name here, or you can, add a new one and then delete this one, right? That is fine. You can get rid of this virtual router if you would like to. And then you can add a separate virtual router in case you would like to add in case you'd like to have two virtual routers, right? So then I can give VR2. I'll click on OK. So this is my second virtual router. Then I'll have to add the interfaces over here, right? What all interfaces I would like this virtual router to have, right? So as of now, nothing is coming. Reason being, we have not configured any of the interfaces over there, right? Once you configure that interface as a layer 3, you will be able to get VR2 as a drop down option, or you can come down to this place and then you can assign that interface over here. But don't worry, I mean, not going to do that right now. We'll see all this in our virtual router module. Okay. And then you have the static route, wherein you will be able to add the static routes. I guess everyone is aware of static routes, right? What a static route is, wherein you will have a destination subnet, a destination, and then you'll have to provide the next hop. Next hop could be an IP address, and then the leaving exit interface, right? So based on this, your packet will be, leaving through any of the interface based on the route lookup. Okay, but static routes could be configured over here. There was a query I remember related to admin distance. I'm not sure who asked me, but if you see admin distance 10 slash dash 240, there is no value pre-configured, but if you'd like to configure it, it will take a range from 10 to 240. But if you'll see, I mean, it is not configured. Okay, this is blank. So for static routes, I'm not entering it, but you can enter it if you'd like. Okay, and then metric is by default 10. You can again play with metric around. Again, not going to go into the routing part as of now because I hope everyone has a basic understanding of routing, what an admin distance is and what a metric is. So admin distance is like static route will have 1, and then your OSPF will have 90, and these kind of things, right? Okay. Deepak. Yeah, Deepak.
If it is the one interface, 1/3 is in one virtual router and 1/4 is in another virtual router, would it able to be route the packets between?
Yes.
Okay. It
Yes.
is
You
not
will
like
be.
we are having different routing tables.
You will have different routing tables, but you will be able to route through whatever packets coming on 1/4, and you want that to go through 1/1, which is on different virtual router. You can point a static route. I'll show that to you. 1 second. So if you see next hop over here, you have an IP address and then you have a next VR, right? So I'm saying that whatever traffic is coming for this particular destination, forward it to next virtual router. Okay, and then you'll have to select the name of the virtual router, and then it will be forwarded to next virtual router, and then that virtual router will be responsible for the route lookup of that particular destination. So we do have that feature.
Yeah. Thanks.
All right, no worries. Cool. Okay. So this is about static routes, okay, how you can add it. And again, there is no admin distance that we are configuring right now for static routes, and then metric is 10 by default. Path monitoring and all, again, I'm not going to discuss right now. As I mentioned, we'll discuss later. uh, Redistribution profile, again, the IPv4 And then you have an option for IPv6. You need to enable IPv6 first if you'd like to play around with IPv6. We need to, we'll see that as well. You can enable IPv6 and then you can play around with IPv6 routing or whatever you'd like to do. Okay, but yeah, we do support IPv6. Redistribution profile is again wherein you have learned few routes from maybe IGRP, and then you like to redistribute into exterior gateway protocol, EGP or something like that. Then you can do it over here, right? So we have a redistribution profile. Then the routing protocols: RIP, OSPF, OSPF v3, BGP, and multicast. These are the dynamic routing protocols that are supported. We'll see, we'll not go too much into the details, but we'll try to see the BGP, because BGP is very important in most of the environments. You'll be able to see BGP and OSPF. These are the two routing protocols that are most commonly deployed. Again, this is not a routing class, or this is not a networking class, so I'll try to cover as much as possible, but certain things might not be feasible to cover. But no worries, I'm still open to discussion to those things. Okay. uh cool. So this was your virtual router. Okay. Where you can go ahead and configure your dynamic routing protocols if you would like. For OSPF, since we have area concept, will PA join on same area with Cisco router? Yes, it can be. So if you see, you can define areas, right? So on a Cisco router, you have area 0. You define an area ID over here as area 0, and then both will be the part of the same area, right? Because the packets, whatever packets are being exchanged, they'll have that area information. So they'll become a part of the same backbone area. Okay, cool. So, but again, let's not go into routing. Otherwise, this class will take forever. Cool. I guess at least you guys now have a overview of virtual router, I believe, right? Any questions related to virtual routers? Let me know. Let's not go into the routing part too, right? Routing part will cover in our virtual router segment. Okay. Will VR have separate CPU, memory, etc.? No, there is no separate thing for VR. So the CPUs are segmented into management plane and data plane. So management plane will have a management CPU, and data plane will have a data plane CPU. So that data plane CPU will take care. So data plane CPU, apart from that, there will be some networking chips that will be there, right? So when you say separate CPU, I mean, there is no separate CPU only for virtual routing, I would say, but we have a network chip that is over there that takes care of route lookups and everything. We call it an ASIC. So yes, but sort of everything is integrated in one system. Okay, but yeah, the network function is carried by a network chip that will be there on the firewall. Okay, but we don't have RAM different for that network or virtual router processing. No, not like that. Okay, not like separate engine. Yeah, I mean, so we have a network chip altogether, right? That network chip is responsible for the route lookups and everything that you are seeing. If a packet comes into it, it will do the L3 header processing and then understand what needs to be done, and where that packet will be forwarded. Everything is done by that network chip. Okay. Is virtual router and virtual system are the same? No, Deepak, virtual router and virtual system are not same. Virtual system is wherein you have for example, you have a chassis box. You want, let's say you want to partition that entire firewall into 10 different segments, right? So that firewall will be a one physical firewall, but you can use it as a 10 different firewalls, right? Wherein you will allocate two interfaces for first firewall, two interfaces for next firewalls, and then you will have a separate security rules for the first VCs, then second VCs, and third VCs, right? So like that, you'll be able to partition a whole firewall. We call it as VCs. So that is your virtual system, and virtual router is again for the routers, right? Routing. Do virtual routers details are available in the syslogs? No, virtual router details are not available in the syslogs. Syslogs are where the logs are being forwarded. If you'd like to see virtual router information, you have to come down over here, which says more runtime stats. This will give you information. I was actually leaving it for the routing part, but no worries. So routing, when you click on more runtime stats, you will get a route table, you will get a forwarding table, you will have a static path monitoring. You can come down here to see more information about BGP. Right now it's not enabled, so you'll not see anything. Multicast, BFD, right? So again, routing, when we'll be discussing routing, there's something called as RIB and FIB, which is route information base, and then forwarding information base. We'll discuss about those. Okay. But yeah, the information, quick information can be available from here. Then there are a few commands that you can run on CLI to get the route tables and everything, right? Cool, guys. We good with the virtual router part? Shall I move to the security policies? What's the purpose of having multiple virtual routers in environment? Can all the routing requirement of a medium-sized, large-size organization be done in a single VR, or is it mandatory to have different? See, it depends on implementation, Srikanth. Okay, it totally is like it's my call, right? Now, what I would generally do, I would like sort of like have a different VR for my voice traffic, right? I would like to do like a separate VR for voice traffic. No one said that you cannot have it in the same single virtual router, but for my operation, I feel like that will give me more convenience. And then again, if my I'll be able to define more. I'll be able to have more granular control having these two virtual routers instead of one virtual router. So I can do that, right? It totally depends on my requirement. There is nothing as mandatory that you will have to have two VRs or three VRs. No, nothing such that. But in large environments, you will see that they have this segmentation because, if you have to do some changes on let's say my LAN environment, why do my other environment have to suffer, right? If you have to do changes in for a particular environment, I will isolate that as a different VR. That gives me like ease of managing the virtual routers or the routes. Does routing management traffic will be taken care by a management plane, data plane? Routing management traffic will be taken care by management plane only. So there is no routing actually. We just have an IP address and a default gateway on the management interface. Again, we'll see that once we head to the device tab. As of now, I'm not covering that, but yeah, management plane traffic. There is no router over there. It's just an IP address and a default gateway. So always we will send the traffic to a default gateway. That's it. So we are not running any dynamic protocol or anything on the management plane. Okay. Cool. Shrikant, your questions answered. Is that good enough? All right, great, man. Cool, guys. So let's head towards the policies tab. I would say this is the most interesting or most significant part of a firewall, right? Because this is where you define the firewalls. This is where you define all the policies for the firewall, right? Uh, Without policies, I mean, there is no use of a firewall. It's just a box, right? So all the security inspection, everything, you can define security policies, NAT policies, QoS, that is your quality of service. Uh, Policy based forwarding, that is your PBF. Again, PBF we'll see in the routing part because this takes a precedence over routing, whatever routing you have before going to VR. If you have defined a PBF, that will take precedence, right? So we'll see this during our routing part. Then decryption policies. If you're decrypting in your environment, it will be present. You can write a decryption policy over here. Tunnel inspection, application override, right? Certain custom applications that I'd like to sort of like these applications are custom in my environment, and I don't want any layer 7 inspection for these custom applications. So I'll come here and define these application override policies, right? Then authentication policies. If you Oh, my Windows machine just crashed, man. Okay, no worries, I have another machine. Cool. So authentication policies, right? Then we have DOS protection and then SD-WAN. So all these are policies that you can define on our firewall. We'll talk specifically about the security rule. Uh, we have already defined and allow any rule and then allow vwire. We have already seen that different types of zones will need different security rules, right? For example, if you are having a layer 3 zone, you're defining a security policy for layer 3 zone, then you should define only layer 3 zones in that security rule. You cannot have crisscross where layer 3 or vwire or combinations of those will not work. Okay. And then if you're defining a vwire rule, I mean, a security policy that references a vwire zone, then all the zones should be vwire. Okay. And one Cisco router supports single AS number in BGP. So different VR can have different AS number in a BGP. Ideally, yes. But again, I'll check on that and get back to you, Srikant. Routing really, I mean, uh, we don't get that deeper. Most of the things will be, already the requirement will be provided to us. But I'll check on that. I think it should be because that will be a separate VR. But let me check on that. Okay, I'll confirm you that. Yeah. So coming to the security policy, uh, no crisscross mechanisms. If a layer 3 zone is being referenced in a security policy, then all the zones should be layer 3. If the if it is virtual router, then it should be a sorry. If it is a vwire, then it should be a vwire zone only. Sorry, guys, just give me a second. Cool. All right. So let's click on add and see what all fields are available to us. So security policy rule, the first thing, when you click on add, you'll get general. In general, you need to provide a name, okay, which is mandatory. Again, the name should be meaningful, right? You can't just name it like 1 2 3 4 and then ABC or whatever, and then later down the time you go back to review, oh, why this rule was created in the first place, I'm not sure, right? So the name should be meaningful always, guys, remember that. Reason I'm saying, right now in lab you might be defining 2 rules, 5 rules, at the max 10 rules. In production environment they could be as huge as 70,000 or 80,000 rules as well. I've seen that, right? So I've seen panoramas handling like 70,000 rule base, and then again people are banging their head, oh, I don't know why this rule was created, or someone else created this rule, so I don't know why this rule was created in the first place, right? So always have a meaningful name, so that by looking at the name of that rule, you'll be able to understand, oh, this rule was created for this. All right. So you can give it like anything, allow it any, or allow YouTube, let's say. Okay, for now let's give it this name. So I'm just creating a rule that will allow YouTube specifically. Okay. Now, rule type is universal right now. You can see there are 3 types of rules that we can configure. One is universal, intrazone, and interzone. Okay. So what is intrazone? What is interzone? And what is universal? If we talk about intrazone, right? Intrazone is within same zone. Okay. Within same zone. You cannot have a destination zone will not be available to you. Okay. There is no destination zone, because if the traffic came on, let's say zone A, the traffic will head back to zone A. Okay. This is what is called as intrazone. If you talk about interzone, it is between 2 different zones, right? Within different zones, right? So traffic came from A zone and now it is leaving to B zone. Okay. This is where you call it as interzone. Okay. Intrazone within same zone. If it is going from one zone to another zone, that will be your interzone. And then you have something called as universal. Okay. Let's say you have A, B, C. These are the 3 zones in the source. And then in the destination, you can have A, B. Okay. So the traffic coming from A can go to A. The traffic coming from A can go to B. Okay. The traffic coming from B can go to A, the traffic coming from B can go to B, and then same for the traffic coming from C can go to A, and the traffic coming from C can go to B. Now, if you see, A to A will be intrazone, A to B will be interzone, right? So this is having a combination of, like, sort of like, in a way you can say intrazone and interzone combined together will result into universal. Okay. Most of the rules that you define uh, will be universal only. I mean, honestly, I mean, I have been working for quite long. I never had a need to define anything as intrazone or interzone specifically. I leave this to default of universal. You can see that is the default value that is configured over there. But in certain scenarios, or certain requirements, you might have to change it to intrazone specifically or interzone. Universal is sort of a combination wherein intrazone and interzone both will be there, wherein you traffic coming from the same zone can be a part of the uh, you know uh, coming from the same zone will be going to the same zone, or coming from the same zone going to a different zone will be allowed, or whatever action is configured will be these parameters will be matched, right? So just see, if I have universal, I have both the tabs, source and destination, available to me, right? If I go ahead and select intrazone, you see source is available to me, but destination is grayed out, right? I don't have an option to select the destination zone, because intrazone means whatever the source was, the destination will be the same. And then if I have interzone, now I'll be able to add source and destination both. Cool. So let's leave it at universal default. Then there is something called a description. This is again sort of a comment that you would like to add over there, that describing this rule was created by me on so and so date for this and this reason. The purpose of this rule is to allow YouTube explicitly. Please do not delete this rule without change request, whatever. Right? You can add all the description over there. Tag is a mechanism wherein you can add the tags to group the rules, right? And then group the rules by tag. Okay, as of now, none is defined. This is nothing but, these two features are nothing but sort of like, when you have 40,000 rules, you will have to definitely organize them, right? You would like to identify which rule is for which kind of, for example, you have LAN infra, you have WAN infra. You want all the LAN rules to be categorized in LAN rules to be visible in like one window, or filter out on that particular rules only and leave everything. So you assign tags to them. We'll see all that in the objects tab when we'll be covering that. But just so you know, this is used for organizing the rules, right? Where you will be able to filter out certain types of rule in just one click. For example, LAN infra, there are 100 rules and you have tagged all the rules with LAN infra, and then you filter that tag as LAN infra, and then all the 100 rules will be there at your display. Okay. Similarly, this is group rules by tag. You can do that for the organizing, right? Audit comment is very important. Generally, in huge environments, they will have their audit mechanisms, procedures. See, it is not mandatory, but you can make it mandatory, right? That we have a mechanism for that as well. But audit comment is nothing wherein you enter, like, there might be a change request based on which you might have created this rule, or there might be a request that you might have received from a user, or there might be a ticket that was raised based on which this rule was created. So you can add all that into the audit comment. So when the audit actually happens, they'll come to know why this rule was created, and what was the request number, and all that information will be present over here. Okay. Source. Uh, Coming to the source, you will be able to add, you have an option of any. Any means any source zone. I don't care. If it is whatever source zone you have defined, trust, untrust, LAN, WAN, voice, whatever is the name of your zones you have defined, any zone will be considered as source zone over here if I select this as any. Okay. If I don't want that to happen, then I can go ahead and from the drop down, I can click on add, and then from the drop down I can select which will be my source zone. So I can add trust, I can add untrust. You can have multiple zones under the source zone. Okay. Depending on your criteria. For example, I can have trust 1, trust 2, trust 3, right? Where I might have segmented my trust environment, or I might have segmented like administrative, executive, associates, accountants. So I might have created 4 zones which are there in the source side, right? So I can add all the 4 zones in one go. Okay. So I'll delete this for now. And then you have an option of source address. It is exactly similar to what ACL we have defined, right? So you can add, this rule is applicable only for the source address coming from this particular subnet. For example, I'd like to say 172.16.1.1/32. I am defining it for the first PC where sorry, it was 1.2. My bad. So 1.2/32. This rule will only take a hit for traffic originating from 172.16.1.2 machine, not for 1.3, right? Or I can make it a subnet, right? 1.0/24. Now it will take hit for all the machines which are there in this particular subnet. That is my source address, right? There is an option to negate. If I click on negate, negate means leaving this everything. So it will take a hit for all the traffic coming, but it will not take a hit if the traffic is coming from this particular subnet. That is 172.16.1.0. Okay. So generally I don't prefer negate, but it again, everyone has a different way of implementing it, right? Is it same for other firewall also? Uh, Poonam, what is same for other firewall also? Can you elaborate more on what particular feature you're asking? Default, you mean the default rule, right? You're talking about this particular rule type. Yeah. So, see, this is particular to PaloAlto firewall. Okay. I am not sure how Sophos or Sonic Wall, how they implement it. This is how it is there in the PaloAlto firewall. So if you have a VM, if you have a physical firewall, or whatever form factor of that firewall, this will be exactly the same. Okay. But for PaloAlto, I'm not sure about other vendors. Cool. So going back to the source zone, source address, we have something as source user. Again, source user comes in the picture when we'll be discussing the user ID, where you can allow or deny particular users only. For example, you might have 10 administrators, and out of that 10 administrator, one administrator is a super user. I want to allow all the traffic for that particular user, right? So I can add his user ID over here, and then I can select the rule as allow, and then all the traffic for that particular user only will be allowed. Okay. So source user ID will come into picture. It really allows you to put granular controls in place. We'll see how that comes into picture and how you will be able to enforce a tighter security with the help of user ID. Okay. Source device, again, this is sort of like an IoT, right? Where you might have a device ID or something like that, or when you are able to identify a particular device, you will be able to add that piece of information over here. Okay. Honestly, I'm like, I never had a need so far, but going down the line, how things are evolving, IoT was not that evolved earlier. Now IoT is becoming a mature market. Then there are device, the device recognition is becoming more and more important nowadays. So it might be needed as we are progressing, right? But honestly, in so far, I have never needed to configure source device as of now. We never know how the need will be coming down in the future. Destination, again, the same. Here you have multicast, any, or select, right? So multicast, we select a destination zone as multicast when we are configuring the multicast routing. In that case, you will have to select this, right? As of now, or any is again to whatever zones you have configured, everything is selected over here, right? That means any. But we want to select a particular zone, untrust. So then you can reference that particular zone over here. Again, you can have multiple zones over here, trust, untrust, and then whatever zones you would like as a destination where the traffic is headed, right? Those zones should be added over here. Same goes for the destination address. Now we are talking about a particular destination address. For example, I want to create this rule for a particular destination that might be a server in my DMZ, or it could be a public address right on the internet. It could be anything. Okay. That destination address I can add over here. Right now it is selected to any. I can again add a particular IP address. I can add address group, or I can add regions as well. Now, this is very interesting. If you go ahead and see geolocation, uh, you can enable this geolocation, then you can add latitude, longitude, right? Or you can select the country otherwise. For example, let's say China, right? I'll not give this. And then you can click on OK. You can see China is added. So destination addresses to all the IP addresses which belong to the country China. Okay, this rule will be applicable. If I then again, let's see America. Okay, so if I do that, Armenia, United States. Okay, I'll click on that. Now, again, the negate is same. If you select on negate, then these countries, excluding these countries, everything will take a hit, but this country's traffic will not take a hit for this particular rule. Okay. So we can go ahead and add the geolocation. We'll see this demonstration as well going down the line. I don't want to cram a lot of information towards you guys, but we will see these things, more granular controls coming in, because we'll be enforcing the security policies, security profiles as well, right? So we'll see this. Okay, cool. As of now, I have selected destination address as any, and then application. You cannot see the IP address of the countries over here, right? There is an IP lookup mechanism from the CLI that you will be able to do, but generally, you cannot have the name of the, I mean, you'll not be able to get the IP. You cannot do a search on the firewall directly. You can do it from the CLI, where there is a lookup command that will tell you that this IP address belongs to this country, but nothing on the GUI. Okay. If you want, then there are other services which are there on the internet. You can, do that IP address lookup, and based on that, you'll be able to understand this IP address belongs to this country or not. But on the GUI, we do not have such facility. On the CLI, you can do a lookup maybe for a subnet or an IP address. Cool. So then destination device, again the same. Coming back to applications, now this is where it becomes very important, right? If you remember, I have named this as allow YouTube. Okay. So if I go ahead and select the application, there are tons of applications that are defined. Let's see YouTube. I selected YouTube, and then uh, my application now says YouTube. Again, you are able to see something called as depends on, uh, where this application ID has a dependency on Google base. You can add it to current rule, and then the dependencies are added as well. A general rule of thumb: dependencies should be included in the rule, so that your app ID works in a efficient way. Okay, so that's a general rule of thumb that you should follow, but it might not be true all the time, right? Sometimes you want to restrict Google base but allow just YouTube. But being YouTube a part of being Google's company, you might have to allow Google base as well at times if you are creating a rule specifically for YouTube. Okay. So here we specify exact applications that I would like to allow or deny. We have close to 4,000 application IDs that you can use. Uh, there are like 4,200 something apps that we have defined on the firewall. Now you would say, I mean, how is there a database where I can look into? Yes, there is a database. We call it as Applipedia, which is there on the internet. You can just go to PaloAlto Applipedia, and you'll be able to filter out or search on the applications that you'd like to enforce security on. You can do a search if it is there or not. So for example, Zoom, you click on Zoom, you'll be able to get an information about that. It's a meeting platform that unifies SD video conferencing. Now this is a parent signature or a parent application. Then we have child application IDs as well. So nowadays you can see we are doing uploads, downloads, so many things, right? So every function is now categorized as an application. For example, Zoom uploading, Zoom downloading, Zoom base, Zoom phone sharing, meeting, right? So now I want to allow everyone to connect on Zoom, but I don't want to allow this Zoom sharing, right? Where they will be able to share any screen or something like that. So I'll create a rule saying Zoom sharing denied, right? The application action will be denied. So that's how you have a granular control. Don't worry, this is just a surface level explanation. We will go in depth. First, let's get acquainted with the information, and then we'll be processing a lot more. Okay. So you can, once you click on this, you will be able to see the information. That description, app ID covers the traffic of file image sharing in 1:1 chat in Zoom, file or image sharing, right? Uh, it depends on Zoom base. Parent application is Zoom base, or sorry, main application on which it depends is Zoom base. And then information, what are the characteristics of this application, like SaaS, internet conferencing, standard ports. What are the ports that this application is going to use is port 80 and 443. It's based on the client server, a lot more characteristics. Okay. So going back to our security policy, this is where you can specify your applications, whatever you like to allow, deny. Feel free to explore Applipedia. It's there on the internet. Just browse through it and see uh, what are the categories, subcategories. If you remove this, you'll see there are these many business system categories, collaboration, a lot many applications are available there. 4,486 applications right now. Cool. I explained depends on is the application. That could be YouTube application ID might be depending on Google based signature as well for a efficient detection, right? So generally we will add those dependencies as well, but it might not be true in every case. Okay, we need to be considerate about what exactly we need to allow or deny. Coming down to service URL category. Now service is the port number. Okay, we have application default over here, and then you can go ahead and have a service. There are two default services like HTTP or HTTPS. If I select service HTTP, that means port 80. If I select service HTTPS, that means it is port 443, right? You can go ahead and add your own services. I'll click on new service. So you see, we need to define the destination port. That's what it's talking about. So I would like to name it as service RDP, right? Can anyone tell me the port number for RDP? Guys, port number for RDP? Nope, not 23, Poonam. 3389. That's right, Godwin. So 3389 is the destination port, and then I can click on OK. There are other informations for what could be source port. Generally, source port would be any, because source port is assigned by your operating system and it will be higher number ports, right? It totally depends on the operating system. So we only define the destination port. Okay. And then session timeout values, these are inherited from the application. So I'll click on OK. You can see now I have service RDP over here, right? So whatever ports you would like to allow, you can specifically define over here. Now you need to understand the combination, how that works. Okay. Uh, I'll do one thing, right? I really, we don't have much time left for today, so I'll not be able to demonstrate it. So I'm not getting into deeper into this, but in the next class, the first thing that we're going to do is the demonstration of this part, security rules. Let me cover this overview today, and in the next class, we will go ahead and have this, lab demonstrations wherein we'll be able to see security rules. What is the impact of having the port numbers and application default? How does that impact everything, right? Because that combination and everything will take a lot of time. So that's the next thing that we can do in our next class. Okay. So just so you know, these are the port numbers. You can either specify the port numbers, or you can select the application default, or you can allow any. Now, any is not a good idea. Reason why? My SSL traffic is supposed to be on port 443, but it is going on 8080. Still, I'm allowing the traffic. Not good. It could be headed somewhere else, right? So you should always have either application default, or you should have specific ports specified over here. Application default means the port number that it is expected that application is expected to have. For example, SSL. Where is SSL? If I talk about SSL, you can see the port number, the default port number that is expecting is 443. So if the SSL traffic is coming on port 443, then only that traffic will be allowed. If that SSL traffic is coming on port 8080, sorry, that rule is not going to match. It will be denied. Okay. So that's what we need to check. But again, I'll give you a very good understanding of this part. Don't worry. We'll cover the lab demonstrations. This is very interesting. This is the most important part of the security as well, wherein do not select any guys. Okay, unless there is a testing going on in the environment, unless there is a custom application uh, for which we don't know the ports or something. Unless there is an exception made, don't select any. Okay. But yeah, we have our option as application default, any, and then you can specify specific ports if you'd like. Okay. You can go to actions. The action will be allow. The action that generally will be present whenever you add a rule, the action by default selected will be allow. You can either allow, deny, drop, reset client, reset server, reset both client and server. Now, I'll tell you one very interesting fact, right? Whenever I take interview, I'll ask a network engineer, okay, you have worked on PaloAlto. Tell me what is the action that you have that you can configure on the security rule. They'll just know two things, allow and deny, right? But that's not true. We have, these many options available: allow, deny, drop, reset client, reset server, reset both client and server. There are 6 options available. You will understand slowly why these many options are there, right? Deny is wherein you are denying the traffic and you are sending a packet back that this is denied, right? So the client or the recipient knows that, okay, this was denied from some intermediate device in the traffic path. Okay. Allow, as we all know, the traffic is allowed. All right. Drop is wherein we are silently dropping the packet. There is no indication. The other person will be waiting for the reply coming back, and then there is no reply coming from the server, and then you will get that error, connection timed out, right? So we are not sending any. So the difference is, in the deny, the browser will come to know that the connection was reset. In the drop, the browser will never know that something went wrong. It is just waiting for uh, you know uh, uh, response from the server. It never receives that response, and then apparently it will time out. Okay. Reset client. In the client server communication, we will send a reset packet to the client only. We are not going to send anything to the server. So the server will server will be waiting for a response coming from client. But again, the client thinks that the reset has been received from the server, and then it will close the connection on its own end. Okay. Then we have the option to send reset uh, to the server, wherein we will send reset to the server. Client will think, okay, server will respond back to me, but the server has already closed the connection because it received a reset, thinking that that reset came from the client. Okay. And then reset both client and server, send the reset in both direction towards client and server. So resets is gonna whenever you see this reset, that means it will send a reset packet, right? And then again, when I say reset, you need to have understanding of TCP, wherein there are flags, right? Sin, ACK, fin, reset. So these are the flags. Then that particular packet will have the reset flag set, and then that by that packet, when the recipient receives that packet, it understands that the connection is being now reset. That is abruptly terminated. Okay. So these are the options. My suggestion: always pay attention to detail. Right, devil is in the detail. If you have that attention or presence of mind, things will be sorted. Okay, so allow. As of now, I created this rule to allow the traffic for YouTube. So I created a rule allow. Then we have profile settings. Right. Mm. You see, for drop, we are dropping it silently, but now there is a tab where it says send ICMP unreachable. Would you like to send this packet instead? So if you say check this, then it will send that ICMP unreachable. If you don't check it, then it will be silently dropping it. Okay. Right, no worries. Let's keep it this. Then we have profile settings. These profile settings are wherein you go ahead and select the security profiles, right? So these are the security profiles: antivirus, vulnerability protection, anti-spyware, URL filtering, File blocking, data filtering, wildfire analysis. There are total 1, 2, 3, 4, 5, 6, 7 security profiles that you can apply to the security rule. Please be mindful, these need licenses, right? If you don't have a license, your content inspection engine will not work. So you need license in order for the content inspection to work. We have already seen what all licenses are actually available for, for the firewalls, right? There are default profiles that you can go ahead and select. Again, I'm leaving this discussion for our security profile part, wherein we'll be applying these security profiles and seeing how that impacts your traffic, how inspection actually will happen, right? But all of these will have a default profile, uh, and the name is very straightforward, right? What is the use of this profile? Antivirus. This is used to detect vulnerability and protect against it. Anti-spyware. URL filtering is used to enforce security for URL, wherein you might have blocked certain categories or allowed certain categories. You can do that. File blocking is to restrict the upload, download, whatever you'd like to do for the file. You can restrict the access or allow the access. Data filtering is for the DLP. And wildfire is, again, we have discussed this, wherein a 0-day attack could be prevented using wildfire. Wildfire is a cloud, sort of a sandboxing environment where these files are being sent for further inspection, and then based on that, we'll receive a verdict on the firewall. Okay, don't worry, we'll see all of these. Okay, log setting. This is a very important feature. Uh, if your log at session end is not checked, you will if I uncheck this, now see log at session start is not checked, log at session end is not checked. So whatever action is taken on traffic, I will not get a log for that under the traffic log. There won't be any log generated for this, right? And then we will be banging our heads and thinking, oh, what actually happened with the traffic? I have no clue, right? So log at session end. And this is the best practice, log at session end, because log at session start, we don't know what happened with the session, right? I mean, the session is yet to end, so you'll not have a lot of information on the session start. We generally do that for troubleshooting. The default or the best practice is to have log settings, log at session end. Okay. We have then log forwarding, wherein whatever logs that are generated for the traffic that was allowed or denied by this particular security rule, we will be forward if we would like to forward those logs to an external server, maybe a syslog server, or send it as an email or whatever. You can attach a log forwarding profile over here, right? We will see those log forwarding profiles as well, wherein you can configure a syslog server, you can configure any other Cortex data lake, or anything where you would like to forward these logs, right? So if you add over here, we'll see where we can forward these logs. Shrikant, don't worry, I'll cover that, because see, as of now, this is just an overview, right? I'll go into that security policy in depth, because that is the crux of the firewall, right? Don't worry. So forward method, you can forward it to SNMP, you can forward it to email, you can forward it to syslog, to an HTTP server, and then you can forward it to Panorama as well, right? Wherein Panorama will be able to query all the logs and display logs from all the firewalls at one place, right? So that is the log forwarding profile. And then there are other settings like schedule. You want this rule to be applicable only during the daytime. You don't want this rule to be applicable during nighttime, or you want this to be enforced only on Monday, Tuesday, Wednesday. Thursday, Friday should not be, this rule should not be in place. Okay. So whatever schedule you want this rule to take place, you can configure a schedule over here, right? You can configure that schedule over here. Okay. Uh, cool. And then this QS marking is in case you would like to do, like, IP DSCP, whatever marking you'd like to do. This is sort of like a quality of service thing, wherein DSCP is differentiated services code point, where you prioritize, like, this particular traffic should be prioritized, or voice traffic should be prioritized. Generally very high level stuff. I mean, honestly, we don't do this on firewall, but yeah, firewall has the capability. You can do it uh, if there is a need, right? But there are multiple code points, right? DSCP code points. For that, you need to understand what a DSCP is, where your IP headers will have that DSCP thing. So you can check that out to understand what is a DSCP. But generally, you will not find it. in most of the cases, it will not be there. And then again, disable server response inspection. Now, client sent a packet, we did the inspection. Now, server has to reply back, and then something was not working fine. Your throughput or the latency of the firewall went down, and now you want to maybe troubleshoot or understand what was going wrong. So, what you do, you disable the server response inspection. So, whatever reply you got from server, we are not subjecting that to security inspection, right? So, and then we see if the throughput of the firewall improves, right? So, again, you would not do it in a production environment. You would not want this to happen because we want every packet to be inspected, be it a packet sent by client or by server. So we don't do this unless there is a troubleshooting or something that is needed, right? So this is this. We'll see about profile groups as well. Nothing grouping of the profiles in one group, and then you can call that group over here instead of those individual profiles is profile group. That's it, right? So this is how you create a security rule. Okay. Now, again, I would have loved to do a demonstration today, but if I start that, it will take at least an hour for me to go in depth and thorough about it, and I think that would not be a good idea. We have already exhausted 2 hours today. We will take up the lab wherein we'll discuss the security policies and everything in our next session. That will be on Saturday, right? Uh, Today, what all things we have covered. So, guys, officially the module 3 is completed. I'll do a lab demonstration of this security policies to cover in depth. Okay. And out of these deployment modes, we have seen layer 3 and vWire deployments, right? There is a lab already in place. You will be able to access that lab. That is your lab 2, right? Which is vWire. L3, whatever deployment we are doing over here, this is L3. Don't worry, I'll touch base on that. I'm not just going to leave it like that. I'll cover that. We'll discuss about it again in somewhat more details, right? L2, I'll see if we can do a lab demonstration. Really not needed, honestly, but I'll touch base. Don't worry, I'll not leave it like that. And then tab deployment mode, I'll try to cover that as well. But again, I'm not sure if lab will be feasible for this or not. I'll try my best to do a lab. But again, these are basic topics. If we give too much time, then we have a lot of things to cover, right? You can see we have like close to 14 modules, right? So I'll rather focus on more important topics like understanding security profiles, security features, IPsec, right? Global Protect. These are very important. So I really don't want to, take up too much time in these things. We will try to cover uh, these things, uh, complete the module 2 security policy on next coming Saturday. This will complete our all the 3 modules. Currently, I will say the module 3 is completed because this was just an overview. Okay. And then we'll start with routing module 4. I'll try to cover module till module 4 in the going week, right? If possible, we'll cover all this module 5. Okay. If possible. See, there's no rush. I am in no rush to complete the course. But again, I don't want it to take forever for you guys that this course is going on and then, you lose interest. So, but no worries. Let's see how far we can cover. My best effort will be to cover till NAT policies. But let's see how much time it takes for the lab replication and everything, right? And let me stop the recording, guys.